Hello, welcome to Math 1324. This is Chapter 10, Section 5, Example 3. Here, in this example, we want to convert the following logarithmic form to exponential form. And, well, frankly, same instructions as the last one, but a little bit different. Because if you look at these, we have log 0.1 equals -1, log 0.001 equals -3, log of 10 million equals 7, something called ln of e cubed equals 3, ln of 1 over e to the 16 equals -6, ln of e equals 1, and ln of 1 equals 0. What's important from this is that none of these have a base, and none of these have a base for a reason, because these are actually special logarithms. They're special logarithms because they have bases that are very common. And specifically, if you see log x equals y, that's the same thing as 10 to the y equals x. In other words, if you have a logarithm written out as log but no base, we assume that the base is 10. This is called a common logarithm. Now, I do have to caution you a little bit. Depending on what textbook you're using, sometimes they specifically say log is actually the next one. I'm not really sure why, but they do. So just be aware of that. Now, what is the next one then, if that's the case? Well, it's the other logarithm that I showed you there. And the other one is this. ln of x equals y. And that would just be e to the y equals x in exponential form. Now, the reason that this is called ln of x, or the reason that we have this, is that it has a base of e. And e is called the natural number. It's 2.718281828, approximately, I think, what was that? 9 decimal places. It's really not just that number. It's limit as x goes to infinity of 1 plus 1 over x all to the x power. But the name for this particular logarithm is that it is the natural logarithm because its base is the natural number, e. Now, why is this called the common logarithm? Well, the base is 10, and the reason that it's called a common logarithm is because, well, base 10 is the most common form of numbers. Why? Because, well, first of all, we have a decimal system. Our numbers are based off of the base 10 system. And, well, why is that? How many fingers do most people have? Now, I'll say most people because, you know, every now and then you get someone with 9, someone with 11, someone with 12. There are different numbers. But for most people, it is 10. So that is what we generally used to develop our numbering system. Not always. There are some cultures that used base 60, actually. In fact, there were 2 different ones. Some, I believe the Babylonians had a base of 60, and if I remember correctly, the Mayans had a base of 60 as well. It's kind of interesting how literally on opposite sides of the world they had the same base. That is a base 60. I mean, that's a huge base. I can't imagine trying to memorize all those. Anyway, I'm sure you would after a while, but still. So these are the logarithms that we have. So we want to convert these. To do so, we want to begin with these logs. And notice basically what that means is that for each one of these, they have an understood base of 10. And so, again, for each one of these will be the exponents. So base of 10 to the -1 equals 0.1. For the next one, base of 10 to the -3 equals 0.001. And then base of 10 to the 7 is equal to 10 million. That's pretty much it for the first 3. For the last 4, I'm not going to really write down a base of e. It's just understood. I'm not going to really, okay, I'm going to write base of e. It's not You shouldn't do this, but that's what is happening here. So I'm going to go ahead and erase those because it just bugs me that that's wrong to do. And so let's just go ahead and just assume that it's a base of e. Now, for each one of these, what it's equal to will be the exponent. So that means that we have e cubed, because we have a base of e, then cubed, equals, well, it equals the argument, e cubed. It's kind of weird. E cubed equals e cubed. It's not that hard. Over here, base of e to the negative 16 equals 1 over e to the 16. And that's just true, because anytime you have a negative exponent, it flips this entire thing to the denominator with a positive exponent. For the next one, base of e to the exponent of 1 equals that argument there of e. So e to the 1 equals e. In other words, base e understood to the 1 power equals the argument there of e. As for the last one, we have e to the 0 power is equal to 1. Now, what's great about this is that anytime your argument is 1, you're always going to equal 0, because anything to the 0 power equals 1 every single solitary time, and we love that. It's fantastic. And, just keep that in mind. Anytime your logarithm, no matter what your base is, as long as your argument is 1, as long as it's a valid base, you're going to get 0 from it. Well, there you go. That's pretty much it. I'll see you in the next video. And of course, have fun.